In this session, we're going to look at lessons 51 through 53. And we're going to start with lesson 51. And we're going to be looking at logarithms and natural logarithms, which on your calculator, it simply means the log button and the ln button. The log button would just be logarithms, and the ln would be natural logarithms. And so we're going to start, and it's going to say write 2.4 as a base 10 and a base e. And so basically it's going to be 2.4 equals, and you're going to put it as an exponent, and then 2.4 equals e. So it's a base 10 and a base e. The way that you do that is you go log 2.4, enter, and you're going to get 0.38. So 0.38 is how you write that one right there. And so that would be one answer. And the other one, you're going to go to the ln button of 2.4, and you get 0.875 or 0.88. So up here we put 0.88, and that would be your answer to that one. Same thing, they just word it a little different where it says find log 2.4 and ln 2.4. Same thing, you would write 2.4 equals 10, and then 2.4 equals e to the, and then you would put those in your calculator. It's the same answers. It's just showing you a little different way that they would ask it. But either way, those are the buttons that you would push, and those are the answers that you would get. In lesson 52, we're going to look at some really fun problems. And it looks pretty similar to what we've been doing, except for they have the 3 there. So we have tan 3 theta equals 1 when you bring the 1 to the other side. And then the question is, what degree is tan at 1? So we go second function, tan to the negative 1 equals, and we discover that it is at 45 degrees. But that's not going to be the only one. Remember, there's always 2. So 45 degrees, and then you're going to try your other options. Remember, your options are 45, 1, 35, 225, and then 315. And what we're going to discover is when tan is at 225, it is also at 1. When tan is at 135, it's at negative 1. So tan 225 is our other answer. Now what we're going to do, because it's 3 times around, we're actually going to get more than just these answers here. So what we're going to get is, because it's 3 times around, so basically what we're going to do is you have 45 degrees, but we're going to go around again, and then around again, and then around again. We're going to go around 3 times. So if you add 360 to 45, we're going to get 405, and then you add 360 to that to give us the 3rd time around. We're going to get 765. Then we're going to do the same thing with 225. You get 585, add 360 again, we get 945. Then to get your answer, so these are the 6, but to get your answer, you're actually going to divide all of them by 3 because they have to be in between 0 and 360. So 45 divided by 3 is 15 degrees. All right, so did that one. 405 divided by 3 is 135 degrees, so we did that one. And then 765 divided by 3 is 255 degrees, so we did that one. 225 divided by 3 is 75. 585 divided by 3 is 195. And then 945 divided by 3 is 315. So these are our 6 answers that are in between 0 and 360. All right, looking at this next one, you have cosine theta over 2. Now before, we had 3 times theta. Now it's theta over 2, or 1/2 times theta. We'll bring this over. You have cosine theta over 2 equals negative root 3 over 2. So the question is, when is cosine negative root 3 over 2? What you're going to find is one of the angles is 150 and the other one is 210. You get negative 0.866. Now, before, remember, we would go around 3 times and then divide it by 3. This one is the opposite. We're going to multiply both of these times 2. When you do that, you get 304/20. Now, 420 is not an answer because it does not go in between those two. So 300 is actually your only answer to this problem. Last thing we're going to look at is lesson 53, and is going to be angular velocity. And it's going to be a unit multiplier problem. First thing I want to do is review unit multipliers. How do we change 40 miles per hour to meters per second? First, you start with the miles. If we're going to be going to meters, we first have to go to feet. 5,280 feet in 1 mile. Now that the miles are canceled, we go to inches. 12 inches in 1 foot. Now the feet are canceled. Now we're headed to meters. We got to use 2.54 centimeters in 1 inch. Now we're in that. Now we're going to go 1 meter over 100 centimeters. Now we're in meters. Last thing is to seconds. This was just our goal, so it's not really in there. We have 1 hour over 60 minutes, and then 1 minute over 60 seconds. Minutes are gone, hours are gone. You can see that we are left with meters and seconds, and that was the goal. Right here was the goal, what we wanted to do. So now we just label it 40 times 5,280 times 12 times 2.54. It's all the numbers that I see on top. We have 100 on the bottom, and then 60 squared meters per second. That's just a review of unit multipliers. Now we're going to go on to angular velocity, which is what we're getting into in this lesson. The formula for angular velocity, or linear velocity, is V equals RW. And V stands for linear velocity, which is like miles per hour. It's what you already know how to do. So maybe you didn't know it was linear velocity, but that is what we were already doing. R is the radius, and W is angular velocity, or they call W omega, which is measured in revolutions per minute. So what they're going to give us is they're going to give us miles per hour, and they're going to want us to convert it to angular velocity, which is revolutions per minute, or they're going to give us angular velocity in revolutions per minute. They're going to want us to convert it to miles per hour. So that's what we're going to do in all of these. I'll show you 2 examples that go from one way to another. The first one says a wheel of a wagon has a radius of 14 inches. So there's the radius, and it's revolving at 40 revolutions per minute. So it has a radius of 14 inches over 1. And it's revolving at 40 revolutions per 1 minute. We can already know that that is angular velocity because it's measured in revolutions per minute. So we're automatically going to be solving for V, which is the linear velocity. We can already know that before we even get into the problem. It just says how fast is the wagon moving in miles per hour. So we can know that we're going to the V, not trying to go and find the W, or the angular velocity. The way that you're going to solve for this is your traditional that you already know how to do, but then there's a new unit multiplier that takes you from one to the other, 2 pi radians over 1 revolution. So you need to add that to your formula page along with the other stuff you're already used to. So let's first take it to radians. 2 pi radians over 1 revolution. And that's going to go ahead and get you out of the revolutions. Now let's take our inches to miles, because our goal is miles per hour. So we're going to go 12 inches over 1 foot, and then 5,280 feet over 1 mile. So the feet are gone. Oops, nope. That's a good classic mistake for you to see so that you don't make it. The 12 inches needed to be on the bottom so that they could cancel. And then the 5,280 feet needed to be on the bottom. So good that you saw that mistake. Then the next one is from minutes to hours, which is really easy. 60 minutes over 1 hour. Minutes cancels. So now we have our answer. We have 14 times 40 times 2 pi times 60 all over 12 times 5,280 miles per hour. Now you'll notice the radians is still here. The radians magically just disappears. It's just understood that it's still there, but it's not written down in your answer. But it is still there. We're going to find that out in the next one. Okay, the next one, it says an automobile whose wheels are 30 inches in diameter is traveling at 40 miles per hour. They want to know what the angular velocity is. Now it's at 40 miles per hour. And then it was 30 diameter, so we know it's going to be 15 on the radius, 15 inches over 1, times W is what we're trying to figure out. And of course the W, they want it in revolutions per second. So there's our goal that we can put over there. Now if we've got to isolate W, so we're going to flip this and bring it to the other side. So it's 40 miles per 1 hour times, or just do our parentheses, 1 over 15 inches. So when this comes to the other side, you got to flip it and bring it to the other side. And so this is all going to equal W. I just flip the equal sign, it's no big deal. Now we've got to get to revolutions per second. Now the radians, remember I said it is there. And so the radians is automatically there, so we just got to make sure that we bring that back in. It's just not labeled. Oh, I wrote that wrong. Should be radians over 1. We can go ahead and go to revolutions using our unit multiplier. It's 1 revolution over 2 pi radians. The radians is canceled, so we're in revolutions like we need to be. We can go ahead and convert inches to miles right here, and then the miles will cancel each other out. So we go 12 inches over 1 foot. There's the inches canceled there. And then 5,280 feet over 1 mile. When we do that, look how miles cancels out. Feet will cancel. We're left with revolutions. Our time is in hours. We need to go to seconds. And so we'll go 1 hour over 60 minutes. And then 1 minute over 60 seconds. And we are now in revolutions per second like we need to be. You see revolutions, and you can see seconds, and everything else is crossed out all along the way. Now we just write our numbers down. 40 times 12 times 5,280 all over 15 times 2 pi times 60 squared, and we are in revolutions per second. So we solve for angular velocity. Not too tough. Watch the video over and over if you need to really get it down. That's it for lessons 51 through 53.